Okay, on 8.5. Okay, so use properties of trapezoids and kites. So there is a lot of information on this first page. So just stay along with me. And so we're going to talk more specifically about trapezoids and kites and our quadrilaterals. So a trapezoid is a quadrilateral with exactly one pair of parallel sides called the bases, and the non-parallel sides are called the legs. The most typical trapezoid that we see is one that looks like this. So this side is parallel to this side, so only one side's parallel. And then these are my legs. Another way to draw a trapezoid would be something like this. Parallel, parallel, and then non-parallel, non-parallel. Okay? So base angles are either a pair of angles whose common side is a base of a trapezoid. So these are base angles. If I were to flip that trapezoid the other way, these also would be considered base angles too. Okay. Isosceles trapezoid is a trapezoid that looks like this, but it has congruent sides. So its legs are congruent, not the bases, but the legs. A right trapezoid, so this is an isosceles. This is a right trapezoid because it has a 90-degree angle here and a 90-degree angle here. Okay, 360 degrees total in a trapezoid, just like any other quadrilateral. A kite. So a kite is a quadrilateral that has two pair of non-consecutive congruent sides. So a kite looks like this. So this side's congruent to this side, and this side is congruent to this side. But in which opposite sides are not congruent. So this one's not congruent to this, and this one's not congruent to this. If I have a right kite, there's two ways I can draw a right kite. The first way looks like this, where my right angle is up here. The second way is where I draw it like this, and this is not going to be the best right kite, but my right angles are right here. So in this case, I have two right angles. In this case, I have one right angle. This angle would not be a right angle. Okay, so Theorem 8.14. If a trapezoid is isosceles, then each pair of its base angles are congruent, which is kind of like what we talked about here, the base angles. So this is congruent to this. Oh, we talked about those being base angles. I guess we didn't talk about if it's isosceles. So here's an isosceles trapezoid. And I know it's an isosceles trapezoid because that's parallel to that. This is congruent to this. That's what makes it isosceles. The two sides are congruent. That means that this angle down here will be congruent to this angle, and this base angle up here will be congruent to this base angle. Okay? If a trapezoid has a pair of congruent base angles, then it is isosceles. So going backwards. So if I tell you I have a trapezoid and this is congruent to this and this is congruent to this, that makes it isosceles. That means that this side is going to be congruent to this side. A trapezoid is isosceles if and only if its diagonals are congruent. So we have a trapezoid. If this diagonal is congruent in length to this diagonal, that then means it's isosceles, so this side is equal to this side. Next one, if a quadrilateral is a kite, then its diagonals are perpendicular. So on a kite, any kite, doesn't matter if it's a right kite or not, if I have a kite, if you draw its diagonals in, what happens is that this hits this guy at a 90-degree angle. So that's going to be a right angle. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So on all kites, this angle will equal this angle. On all kites is what this guy is saying. Okay, with all that knowledge, go ahead and turn to the next page of your notes. And let's plot these. Back 2 up 3. That is A. Over 3 up 3. That is B. Back 1 down 2. That's C. And over 2 down 2. That's D. Decide whether it's a trapezoid. So a trapezoid, we have one pair of parallel sides. So I would have to prove that AB is parallel to CD. 1, 2, 3. So this has a slope of 0, and this has a slope of 0. So that is parallel to this. I would then need to parallel or prove that these two are not parallel, and I can do that because this is a negative slope. AC is negative slope, and BD is a positive slope. So there's no way that those could be parallel because they have to be exactly the same. Next one, back 3 and up 2. Back 3, 0. 4, 3, 1, 2, 3, 4. 1, 2, 3. And back 2 down 5. 1, 2. Did I plot this right? 1, 2, 3, 1, 2. Oh, that's not where B goes. B goes at 1, 2, 3. 4, 3. I'm assuming there. Okay, and this is actually ACBD. So we would have to prove that one of these sides is parallel, but I can just go by looking on this, or I could do the math, but none of the sides are parallel. So no, not a trapezoid. Okay. Find the measure of F, G, and H. So this one is an isosceles trapezoid, so that means this angle is congruent to this angle. So angle H is equal to 110. And then this angle is congruent to this angle, but we also need to remember that there's 360 degrees inside this quadrilateral. Another cool thing about isosceles trapezoids is that these will be supplementary and these will be supplementary. So angle F and angle G are actually congruent because they're base angles. And if this is 110 and it's supplementary to this would be 70, which is the same as G, 70 also. So angle F will be the same as angle J, so 68. And then these two will be supplementary and these two will be supplementary, so 112 and 112. So this is a kite. Find the missing angles. So kite again has 360 degrees. We're going to subtract off the two angles that they gave us. So if I do that, I get 236. And if you remember, this angle is going to be congruent to this angle. So the angles that are formed from the sides that are not congruent are congruent, or those angles are congruent to one another. So if I divide by 2, I get 118. So angle E and angle T both equal 118 degrees because I took that, what was left over, divide by 2 because they have to be equal. On this one, these two are going to be congruent, so that's 88. So I have 360 minus 107 plus 88 plus 88. So I just added those three angles together and I get 283. So I'm going to take 360, how many degrees are in this whole thing, minus the 283. And I get 77 for angle S. And then the last problem, use theorem 818 in the Pythagorean theorem to find the side lengths of the kite. Okay, so this is 3, this is 10, this is a 90-degree angle, right? So I'm going to do 3 squared plus 10 squared equals c squared, which is my w to t. So that's 109, so I'm going to do square root of 109, which if we just left it as a radical, it would be radical 109, which is equal to 10.44. So this is 10.44. This would be equal to that also, 10.44. To find this triangle, right triangle, to find that side, that's another hypotenuse. So that's 3 squared plus 7 squared equals c squared. So that's 58. So that'd be square root of 58 equals c. Or, if I actually took the square root of that answer, I get 7.62 for EW and ES. Okay, next one. Okay, so this is equal to this. I'm sorry, it's not equal. This side, well, this side is equal to this side. So this length is going to be equal to this length, and this one equal to this. So you're just doing Pythagorean theorem again. A squared plus b squared will give me that c squared. So 9 squared plus 8 squared, that's 145. So I'm going to take the square root of that answer. So I get 12.04 for that side and 12.04 for this side. And again, all I'm doing is Pythagorean theorem on this, guys. So on the next one, 7 squared plus 9 squared, 130, so square root of 130 is 11.40. And that's 11.40. It did say in simplest radical form. So again, this one would be square root of 109. This is actually square root of 58, and I don't believe that that reduces down anymore. These would be square root of 145, and I don't believe that reduces down anymore, and square root of 130. Okay, so 2 things that you need to do. There is a supplemental packet sheet, 8.5, that is pages 9 and 10 in your supplemental packet, so you need to do that. Pages 9 and 10, and then also the Schoology homework assignment. All right, thanks, guys.